Welcome back to the next lesson on Chapter 8, Rates and Equilibrium. Okay, you know we're concentrating just on the rates section at the moment, so it's the rates of reactions. You know the drill now, so you know how we're going to start. We've said that reactions occur when particles collide with enough energy. There's that picture again, got the red and the blue particle, they're colliding, and we're assuming that they've got enough energy. We've talked about how we can make more collisions and more frequent successful collisions. And we've discussed how if we increase the surface area of a solid, there'll be more particles exposed. So there'll be more frequent collisions. We talked about if we increase the concentration or the pressure, there'll be more particles in a given volume. So there'll be more frequent collisions. Then we also talked about how we could increase the energy of the collisions. How do we do that? We increase the temperature. If we increase the temperature, we don't make more particles, but we do give the particles more energy, so they move faster, so there'll be more frequent successful collisions. And more of the collisions will have the activation energy. But there is one other way we can increase the rate of reaction, and that way is using a catalyst. So once you've got some lined paper, we'll get started. So we're going to look at catalysts, and we're going to investigate how catalysts affect reactions. Now, if we were in lessons, I'd show you an example of a chemical called hydrogen peroxide. Now, hydrogen peroxide has got the formula H2O2. H2O2. You'll have heard of it because it's in some hair products. But when we buy hydrogen peroxide, it starts to break down, it starts to decompose. What two things do you think hydrogen peroxide decomposes into? Now, many people would say hydrogen and oxygen, but that's not correct. It decomposes into a liquid and a gas. What might they be? Well, it decomposes into water and oxygen. Hydrogen peroxide decomposes into water and oxygen. Now, so we'd have this reaction. H2O2 goes to H2O and O2. Hydrogen peroxide, H2O2 is a liquid. Water is obviously a liquid. What would we see in this reaction? That's right, we would see bubbles of oxygen. Let's balance this for you. I'm sure you've already done this at home. Now, the hydrogen peroxide would decompose into water and oxygen, but it would decompose slowly. So we barely see any bubbles of oxygen being formed. However, if we add a catalyst, the reaction is a lot faster. Now, the catalyst we would use on this experiment is manganese dioxide. If we add a catalyst, and this one is manganese dioxide, the reaction is much faster. This is a very famous experiment to do at school. Often it's called elephant's toothpaste. So if you get the chance, I've gone on YouTube and Google elephant's toothpaste, and you'll see this reaction happening. They start with hydrogen peroxide, they add a catalyst and some washing up liquid, and it generates gas very, very quickly, which obviously makes bubbles in the washing up liquid, and it forms up quite dramatically. You might have seen me do it. This is an example of a reaction that's much faster when we add a catalyst. So that leads you to the question, what is a catalyst? Well, we know it speeds up reaction, so it's a substance that speeds up a reaction without being used up. So a catalyst can speed up a reaction, but it itself is not a reactant. It doesn't get used up. So the same catalyst could be used over and over and over again and would always act as a catalyst. It doesn't lose that property. So if we did the example previously in school with manganese dioxide, at the end of it, we'd collect the manganese dioxide, we'd dry it out and remove the water, and we could use that same catalyst again on another experiment later on. How do catalysts work? This is the important part. So we know that for a reaction to happen, the particles have to collide. They also have to collide with enough energy. What do we call that amount of energy that particles have to collide with? We call it the activation energy. So some reactions have a high activation energy. That means the particles need lots of energy before the collisions will be successful. What a catalyst does, it lowers the activation energy. Catalysts lower the activation energy by providing an alternative route for the reaction. That's quite a complicated idea. But we'll say it again. Catalysts lower the activation energy. They do not give the particles more energy. What's the only way we can give the particles more energy? By increasing the temperature. Catalysts lower the activation energy. They lower the amount of energy that's needed for the collisions to be successful. They do that by providing an alternative route for the reaction, which is quite a complicated and abstract idea. But if we can learn that sentence, and then this next picture may help. You've seen this before. We've got our reactants. For the reaction to start, we have to put some energy in. We call that the activation energy. Do you remember, what do we have to put energy into a reaction to do first of all? That is to break the bonds. Then energy is released as new bonds are made. This is an energy level diagram for what type of reaction? It's an exothermic reaction because the products have less energy than the reactants. So on this, you can see for the reaction to happen, we have to put all that energy in to get to the top level there, the blue line, or the reaction will not happen. I would make a note of this diagram. But what's a catalyst going to do? It lowers the activation energy. So we could draw a second line now. This would show the activation energy with a catalyst. You can see I don't have to put as much energy in for the reaction to be successful, for the collisions to be successful. So if I lower the activation energy, more of the collisions are going to be successful because more of them have the activation energy. It's a really important diagram. Now, if we were in school, importantly, different reactions need different catalysts, so we would use certain catalysts for certain reactions. Which one would we choose? We'd choose the ones that lower the activation energy the most. Different catalysts will have different effects on different reactions. And hopefully you remember, when we did a topic on the periodic table, that many catalysts that we use are in which section of the periodic table? The transition metals. So transition metals are often very useful as catalysts. You may also have come across the word catalyst in biology. Where does it come up? What do we call biological catalysts? Enzymes. Enzymes are biological catalysts, so they speed up reactions. Now, I've had a lot of people saying they want to do more graphs, so we're going to do one more. This is going to be a graph of the hydrogen peroxide experiment, where we do it once with no catalyst, once then with a catalyst. This is our results that you're going to have to plot. Again, time on the x-axis. There's no units on this graph, but the time will be in seconds. The volume of oxygen given off will be in centimetre cubed. So you're going to complete this graph. So one graph with 2 lines on it. Pause the video there as you get the details down. Then you're going to answer these questions. You're going to calculate the average rate of reaction in the first 20 seconds without a catalyst. Then calculate the rate of reaction for the first 20 seconds with a catalyst. Then you're going to try and draw a tangent to both curves at 30 seconds, and you're going to calculate the rate of reaction at 30 seconds, so by working out the gradient at 30 seconds, and then you'll explain why the reaction is faster with a catalyst. So just to summarise, what is a catalyst? It's a substance that speeds up a reaction without being used up. How do catalysts work? They lower the activation energy by providing an alternative route. Okay. Any questions on this? Ask your own teacher. Okay. Hope that's made sense. And that's our final lesson on rates of reactions. I'll do a summary of the topic shortly. Hopefully that's okay. Thanks very much.